So this week I've focused on adding the ACL and PCL ligaments, and I've also reworked the strands that I was using last week to be able to specify a number of fibers that make up each strand. So it's coming closer and closer to what a ligament would actually look like. So let's have a look at how this looks within Omniverse. So let's refresh our memory on what we had last week. So last week we'd replicated the MCL and the LCL. So MCL on the inside and LCL on the outside. And if we remember, what happened there is we had some lateral stability. So if we move to the side, that is resisted. And if we move to the other side, that is also resisted. But now we've added the ACL and the PCL, which are these two ligaments in the middle, and they make kind of an X shape. They call the anterior cruciate. Cruciate means cross. So what that's going to do is that's going to give us stability forwards and backwards. So if the calf moves forward, it's going to resist it moving too far in alignment with the thigh. So if we run it here and we try and pull the calf forward, we see the ACL is resisting going forward. And if we see trying to pull back, we see the PCL is resisting going back. So they are both doing their jobs in a very rudimentary or crude way. And then it also gives us rotational stability. So if we try and twist around, we can see that stops twisting. It doesn't want to twist beyond that point. And if we try and twist the other way, that's also giving us rotational stability. It does not want to twist beyond that point. So another thing you'll see is I've also changed the strands so that they have got multiple fibers. There are 3 fibers in each of these strands, and I'm going to show you in a separate screen exactly how those strands are built up now. Okay, so here we have one of the strands made up of 3 fibers, and let's break that down a little bit. If we look at the parent strand X form, it contains 3 fibers, fiber 0, 1, and 2. And if we go into a fiber, the fiber is an X form as well, and that has got the alternating elements. So there's element 0, 1, 2, 3, 4, and 5. And then there are the joints in between each of those elements, joints 0, 1, 2, 3, 4. And these are alternating spherical joints with prismatic joints, just the way I happen to have done it with this JSON configuration. And then we see right at the bottom of each fiber, we've got end attachments. So if we go and we look at the bottom of that fiber, that last element of that particular fiber is attached to the block that's hanging, or in the case of the knee, the attachment joint of the knee. And then we can see the same for fiber 1 and fiber 2. And again, that's just repeated. So we've got 3 fibers with all of those elements repeated. And as I said, the top strand is an X form, and then each of the fibers is an X form. And then if we run that, what I find absolutely amazing is I've obviously written no extra code here, but already it completely obeys the laws of physics. So originally when I had 1 fiber and I would spin the box, it would just continue to spin because there was a spherical joint there. But now because there are 3, as they entangle with each other, it actually stops the box from spinning, and we have a really faithful to physics interaction with this box here. Absolutely amazing. So let's go ahead and create a strand with more than 3 fibers. So we're going to select our box there, and we're going to go to create strand, and we will select the box we want to create it on. And let's create actually 30 segments, and our fiber count, let's say, will be 6, and let's see what that does. So we go ahead and add that, and we can see there 30 segments. And if we zoom in, we can see the way they are arranged is in a circular fashion. And let's just see that running. They sort of will pull freely. We can see they sort of all hang there, and we can pull them around. And we can see if we add a box on the end and we play the simulation, that will have all 6 of those fibers acting in unison. And there we can see if we try and spin it around, it twists, but then entangles with itself and then starts to swing the other way. And we've got a little bit close to what an actual ligament looks like. Obviously, orders of magnitude fewer items than an actual ligament, which would, I guess, be millions or billions of fibers and cells, which I will try and replicate with a point instancer. But for now, we're getting a little bit more fidelity as we add more strands, more fibers to the strand and more elements. Okay, so that's it for this week. Looking forward to showing you what I've done next week. And if you're enjoying this content, please consider liking or subscribing. Till next week. Ciao, ciao.